Started. Hello, everyone. Welcome to the MIT Mobility Forum. This is session 180. We'll discuss the geopolitics of mineral supply chain for transportation. There has been immense effort to decarbonize transportation, particularly through the electrifying our mobility system. But there is an inconvenient truth. The electric vehicle production depends on materials that we do not produce in the United States. Supply chain run overwhelmingly through one country, China. If you look at a clean mobility system, lithium graphite in the electric vehicle battery, cobalt in the high energy cell, neodymium and dysprosium in the permanent magnet, rhenium and nickel in the jet turbine blades, the upstream supply chain are highly concentrated in China. China mines 60% of world rare earths, process 80% of them, and produce 90% of its high-performance rare earth magnet. And this is no longer just theoretical in 2025. Last April, the export control on heavy rare earths were introduced, and car makers in the US, Europe, and elsewhere scramble to secure permanent magnet. A negotiation suspension followed in November. It runs through this year, November, so we're literally in the middle of it. Last week, President Trump and President Xi's summit in Beijing, both sides announced progress, and China committed to address supply chain shortage. It agrees to ease restriction on rare earth processing equipment and technology. It's a step forward, but the fundamental concentration remains. So that's why, under this context, John designed this session with Tomasz to really introduce us to the basics of the raw material supply chain in the world. So good to you, John, for the introduction.
Super. Okay, thanks so much, Jinhua. So I thought it would be useful just to build a little bit on Jinhua's introduction with some context for how this topic of critical minerals actually relates to transportation and to our mobility system. So let's just start with the question, what are we actually talking about here? What do we mean by critical minerals? And here in the United States, the US Geological Survey defines this list as critical minerals, which includes what's known as the rare earth elements. And so the definition is really built around things that are essential for not just economic security, but for national security. And I can tell you just as a side thought that for many, many years, I organized these high-level meetings for transportation officials, and I never heard the term national security in a room full of, say, CEOs from the car industry. It really wasn't something that was talked about. And all of that really started to change about 10 years ago. And national security entered into the lexicon of these conversations around mobility and transportation systems. So there is a national security component. There is a kind of criticality, as the name implies, component as well, where disruption would be really, really bad. And finally, that these materials serve an important function and add value. So here at MIT, we recently released a joint report with Harvard on this Roosevelt project. And there's a lot to unpack in this report. I mean, the first thing is what we just heard about the core definition of critical minerals. The second point is really that, how did we get here? And part of how we got here is through a sustained period of underinvestment in both extraction, mining of these minerals, and the processing of the minerals. And that's really a sort of third important concept, is that it's one thing to extract, to mine, to pull raw materials, say, out of the ground, and it's another thing to process those materials into compounds that are useful for transportation and for other elements of our economy. And as Jinhua alluded to, China has a particular concentration around especially the second processing and refining component. And that's shown in this chart from the International Energy Association that basically makes the distinction between how oil and natural gas are much more geographically diverse, spread out, and these minerals are far more concentrated, both in terms of the extraction, the mining, and in terms of the processing. And you can see the sort of influence of China in particular on the processing side. So let's take just a brief history of what's happened over the past 14 months or so. The US announced very strong tariffs. For every action, there's an equal and opposite reaction. China responded. Then we saw this evolution toward this trade truce between the US and China. Um, but it was really meant to last for just 1 year. And then, as Jinhua mentioned most recently in the summit, um, there's no clear resolution coming out of that discussion with respect to rare earth elements. And Tomas will be very interested to hear your perspective on this as well. The clean energy, these critical minerals are important for the clean energy transition in general. What you see here is a comparison between a traditional internal combustion engine vehicle and an electric vehicle. And you can see the extra concentration of critical minerals and materials. Obviously, the cobalt and the nickel and the graphite and the things that go into the battery of the vehicle, and similarly for renewable energy, wind, solar, etc. And it's the same story for mobility industries. So these critical minerals are essential for batteries that are used throughout the transportation system, for motors, for coatings on turbine blades and jet engines, for LiDAR, and for many, many other applications across the transportation system. So that's why this matters for mobility. If we just look a little bit deeper for critical minerals that supply batteries, anodes, one of the key components of any battery are more or less almost completely graphite based across electric vehicles. And the production of graphite is heavily, heavily concentrated, and the processing of graphite with China and Chinese entities. For the different cathode chemistries, we see a lot of these minerals and materials showing up. For the electrolyte itself, requires lithium. So if we break down sort of the core components of an electric vehicle battery, this is from a few years back, but still quite relevant. We see the presence of China in the value stream of electric vehicle batteries. And we can see it from this view as well when we look specifically down the value flow, moving from way upstream to a finished battery, looking at the production of lithium, nickel, cobalt, and graphite that goes into that battery. Similarly, for electric vehicle motors, same story, a number of rare earths that I can barely pronounce, so I will not attempt to do so. But you can see from Benchmark Mineral Intelligence, they cite, just how much of these materials are required for the formation of the magnets and other components of the battery. And again, it's a similar story where China is very much dominating these critical rare earth elements. And the figure on the right shows the share just over the past 20 years, where China now is effectively producing about 94% of the sintered permanent magnet motors. Similar story for the coatings on jet engines. The hotter that jet engines can operate, the more efficient they are. So there's an incentive to bring those temperatures up. And these materials, again, that I can barely pronounce, are used in the coatings of those jet engine turbine blades. We see it in LiDAR as well. This picture of these two goofy guys, I don't know who they are, standing in front of a Waymo and looking at that little spinning machine on top. I mean, that also uses a number of these critical minerals. So this is all to say this is why this matters for what we look at within the mobility system. And with that, I'd like to turn it over to Tomasz Nadrowski. Tomasz is actually a former colleague at mine. We worked together 25 years ago at the World Economic Forum in Geneva. He's portfolio manager with Amvest Capital in New York, and he's authored a recent book called Mineral War. And so that's what we'll focus on for the conversation today. In addition to his previous roles in finance, Tomasz served as the VP of Corporate Development at Anglo Gold Ashanti in Johannesburg, as a director of the mining and metals industry at the World Economic Forum. He's fluent in 7 languages. That always amazed me when we worked together in Geneva, and holds an MPA from the School of Economics at the University of Geneva. So with that, over to you, Tomas.
Super. Thank you, John. Thank you for this opportunity. It's great to be together with colleagues with whom I worked, probably at the time of the Roman Empire. And I'm very humbled sitting also across from Professor Zhao. Here where I'm sitting, running a small hedge fund in New York, we usually look up to people like Professor Zhao and other beautiful minds who actually create the future. The only thing we're doing is trying to guess it, and often not very well. So this is just to put a little bit of context of our inductive logic within which we function. But as John mentioned, in the process of running this portfolio, I decided to explain a little more about why we got into this situation that John kindly presented with slides. Just a moment.
Tomas, could you pull your mic closer to your mouth? That's not.
Yep.
Thank you.
Okay. All right. So this book basically traces the history of why this happened, why we have that level of overdependency on just one country that's so dominant in refining, processing, smelting, sometimes mining of these different critical minerals, which are important, of course, for mobility, but as John mentioned, also for national security. So let's just start with that. So October 25, following the attempts of the US administration to rebalance the lopsided trade relation between US and China, we observed this really important moment, which probably leads us to a conclusion that the trade war of 2025 was won by China. It was won by China because of the leverage that critical minerals represent. And it's important to understand 2 aspects of this. One is the actual monopolization of these different materials and those value chains. And the second one is the weaponization of that monopoly. These are 2 separate issues. So let me start with that approach that the US took to these negotiations since the beginning. So since what John just brought up, the Liberation Day. The view of the administration was, well, China has a massive trade surplus or current account surplus vis-a-vis the United States. Therefore, it has more to lose from the trade conflict. That's not exactly what happened, because the US administration underestimated the leverage that, for example, control over rare earths represents. And this is what this slide purports to explain. If you sell soybeans to China, the soybeans cost about $11 per bushel when you sell them, say, out of the port of New Orleans, and roughly the same in Ningbo in China, where they are received, plus the insurance, logistics, and transportation. There's not much difference, gonna be what, 15%, 20% markup maximum, maybe more now with maritime insurance going up, but that's the usual situation. That's not how it looks with the rare earth. Rare earth oxide themselves, the entire market at the time of this negotiation in Busan was worth about $6 billion. So $6 billion, we know people who own a lot more in their accounts. That's not a big deal. The problem is that downstream, that includes mobility, it translates to a value of about $10 trillion. The $10 trillion, that's already 8% of the global economy. That's the size on the PPP basis of the Indian economy. That's a massive leverage. And the US government just didn't have a full grasp of what it means for the downstream industry to be so dependent on this otherwise small upstream sector. Sorry, I'm going to go back. Okay, so this is similar to some of the charts that John showed, a lot more granular. So going into a couple of different materials that are not necessarily battery materials, but are significant value for new technologies. Of course, spheronized graphite is on top for anodes, heavy rare earths. So the majority of rare earths are actually heavy, but they are more difficult to separate and more rare than light rare earths. They are more generally available. Gallium, very important, for example, for optoelectronics and power electronics, so an element in semiconductor production. And then all the others, as you see here, all of these are dominated by Chinese production, with the remainder being outside of China. Why was this possible for China to monopolize this? Well, there are 2 or 3 parts of that answer. I'll give you just 2 elements. One is, again, this usually underestimated wealth of the subsoil in China proper. We don't think about it because foreigners cannot really invest in mining in China. I never really could. I tried myself with Anglo Gold for many years, just knocking on doors. That never worked. But what's there is very interesting. So surprisingly, for those who remember something from geology, the southern craton, the Yangtze Craton, was part of Gondwana. Gondwana, this massive supercontinent that gave us South America and Africa and Australia and all those other parts of the world that we associate with metalliferous potential, with metal ores. And Yangtze Craton is extremely rich, not just in rare earths, certain lithium, there's tungsten, there's tin, there's germanium, there are many other metals. Of course, there are other parts of China that are also very rich. So that's one reason. But of course, we know a lot of countries that are geologically rich that have not managed to develop their downstream manufacturing, refining, processing, not to mention monopolize these. So this is the second part of the story. The second part of the story is that China has, from the beginning of its reindustrialization process or industrialization process in the 80s and 90s, focused on industrial parks, special economic zones, where a lot of different industrial operations are clustered together. There are economists in the past who wrote about it and wrote history of such clustering. It proves to be extremely beneficial when you have to deal with byproducts and when you have to deal with waste material. And this chart just illustrates the material which was on top of that comparison, spheronized graphite. So this is exactly the bottleneck in terms of graphite production, not so much mining itself, not so much coating for precursors, but just in the middle, making those flakes into little spheres. And why is it so complicated to replicate? Well, because China has those SPG plants, so spherical graphite, spheronized graphite plants, in the vicinity of their chemical plants and their steel plants. Now, how is this impossible to recreate? Well, it's impossible to recreate because China has 360 integrated steel mills. We have 8. Europe has 24. What about the chemical plants? Well, these chemical plants will have to produce hydrofluoric acid. Most of you would know that this is a very toxic piece of chemistry, sufficiently toxic to create problems in terms of transportation over long distances. So it has to be somewhere close to this plant. Well, there are 77 plants, chemical plants in China producing hydrofluoric acid. We have 3 in the United States, and there are 8 in Europe. So it's important. It's an important ingredient for the production of spheronized graphite, which production generates this waste, this low value, very fine graphite that goes into steel mills. And so you have to have all of this in relative proximity. And this is why most of the graphite in China is actually mined in the north in Heilongjiang. But the production of spheronized graphite is mostly in the southern part, where many of these industrial centers are located. This is still happening. Apologies for these. And so this sort of dominance that sometimes includes mining, but always includes refining and processing, leads to an opening for China to control entire value chain. And this chart illustrates rare earths. So let me just explain what happens across the entire supply chain, from mining to sintered magnets. First, the mining operation has to generate some feedstock, either in the form of concentrate, so some mixed powder, or mixed rare earth carbonate on mixed earth oxide, and that product will be later separated. This mixed oxide separated. Here, it's dissociated between light rare earths, all REE, and heavy rare earths. And that separated oxides, separated because there's 17 of these elements, in reality 16 in nature, but let's say a number of those, so they have to be separated among themselves through usually solvent extraction, very complex plans with 950 nodes, because imagine the number of permutations you can have between those different elements, including the also reagents that you're using there. And then once you have this separate oxide, you have to metallize it, usually for reduction, metallothermic reduction. And then there are alloyed with some other elements in order to make magnets, sintered magnets or bonded magnets with polymers. And so, as you see on this chart, China controls every single node in this value chain, and there's no other country like this in the world. There's no other country. There are certain countries that mine it. There are century countries that, because of cheap labor required for this, focus, for example, on metallization. And there are certain countries, mostly industrialized economies, that make sintered magnets. But of course, if China decides not to export sintered magnets or rare earth oxides, and by the way, these restrictions relate to both, then of course the rest of the world is in trouble. It takes many, many years to redevelop this entire value chain. I'm sure we're going to talk about it a bit later. So now, from monopolization to weaponization. I would love this, this chart that John showed, that the mankind started in April of 2025 to be true, but it's not true. It started long before. In Chinese case, probably in 1949. But it continued under COVID in August 2020, when China passed export control law in October of 2020. And that for me was such a kind of catalytic moment, because I decided at that point to create the fund that focuses entirely on critical minerals outside of the Chinese value chain, because it reminded me of a moment of conflict between China and Japan 10 years before, where China used rare earths as a leverage for national security reasons in a dispute with Japan over some islands in East China Sea. Following that law in 2020, China introduced 23 different restrictions on a variety of critical minerals, some of them rare earths, but you see on the right here that there are different minerals involved in this, as are also pieces of technology, equipment, extraction, processing, IP, and so on. So some of it's technology, some of it's the actual material, metal, or compound related to this, or an alloy related to this. That truce with which I started suspended 4 out of those 23 restrictions. 4 out of those 23, conditionally until November of this year. Everything that we've heard so far is just words. There's been just no agreement. So both views of the world that Jinhua and John just presented are true. We don't have a solution. I don't expect any solution until November. In fact, since the beginning of this year, China slapped new restrictions, this time specifically on Japan, regarding the flow of these materials. And Japan is the largest importer of Chinese magnets and Chinese rare earth oxides. Now, this slide illustrates how long it takes, if we were to rely on mining, how long it would take to rebuild this industry. So a large open pit copper mine or nickel mine, that's about 15 years to 17 years since the discovery or resource definition to the actual commercial stage production. In TSMC, take about 2 years to put up a foundry that is extremely hungry for many of these materials. So this is a problem. The timelines are completely disconnected, the supply timelines from the demand. Many people, of course, point to recycling, and I'm sure this is a topic that might return later. This is from IAI again, International Energy Association. They are a bit skeptical about some of the materials. Lithium has a lot of problems. I think rare earths, this situation is improving because e-waste is a real business. But other than those really well-established materials, the loops are difficult to build, and often it's simply not economic to process, especially if there's a very high volatility of this product. And finally, one of the reasons why there is so much alarm about this situation is what John mentioned. This is also related to national security. And this is where the definition of criticality changes. So critical minerals are critical because of a structural demand pull, let's say, right now, potentially a Kondratiev sort of cycle kicking in. On the other hand, potential supply distortions or constraints on supply. And the third one is, of course, substitution risk. But the timeline matters really in a very different way as we're moving from just in time to just in case. And of course, in the natural security sector, this is just in case right now, which of course bids up the prices for all of these materials. So yeah, that's my initial remarks. I'm looking forward to the discussion.
Great. Thank you so much, Thomas and John. John, maybe we can alternate or we can both ask questions. So Tom, let me start with the more kind of institutional design here, right? So in China, there's this 5-year plan introduced by the National Reform and the Development Commission every 5 years. Mm-hmm. And the country seems very well coordinated and strategic about these types of critical minerals, energy, semiconductors, AIs, etc. This, right? In the United States, can you educate us on, in terms of this mineral and rare earths, who's responsible for that within the United States?
This is a great question because it seems like we have almost too many cooks right now. Why do I say this? When I look at different companies across the spectrum, from mining through recycling and processing, that received some kind of support from the government, I see their DPA, DLA, DOD, DOE, DFC, EXIM, Department of Commerce recently. That's already 7 different cooks, right? So there is, I think there should be a legislation. We cannot just bump from one executive order to another. And I'd like to be more optimistic, because one of the things that's blocking, if we stick to mining, is blocking development or redevelopment of mining industry in this country is permitting reform. The permitting reform, of course, affects transmission lines and so on, but mining could be revived this way. And Joe Manchin had a piece of legislation ready in late 24. But following the clean sweep in the elections in November, this was not pushed into the omnibus and was sort of postponed until 2025 because, we've won. We're going to have a better legislation. This is May 26th. We still don't have permitting reform. And by the way, some kind of courtroom reform will also help, because often you have this last person standing, blocking, a development. And we know from history that these are the type of polities that collapse if everybody has a liberal veto, as it's known historically. So very good question. I'm afraid, right now there's a lot of momentum for the administration, and different parts are responsible for different things, but a bit of a creative chaos.
I see. The second question is, it seems this is not the first time U.S. fall into this kind of difficulty. This was similar in the energy crisis, mineral, semiconductors. This seems to happen again. This, right? Yeah. Give us a sense, first of all, what's the difference between this mineral security versus the energy security versus the semiconductor security? You hinted at one of them being the timeline, right? Semiconductor, you said 24 months, you can build a mineral much. Any other major differences between these different categories? Things?
So the major difference is, of course, geopolitical. So if we take just the energy, the 1973, 74, Secretary Simon going to Saudi Arabia and basically inventing petrodollar, right? So we're gonna offer you protection, security. You're gonna pay us. You're gonna pay us in our own currency, and reinvest in our treasuries. And everybody who's actually purchasing oil and gas from you will pay with our currency, right? The petrodollar was born in 1974, finishing 3 years of a transitional period in FX markets. So geopolitically was solved. Semiconductor is not a problem because adversaries are not part of the top value chain, right? It's really about logic chips in Taiwan and memory chips in Korea, lithography in the Netherlands, photoresist in Japan, optics in Germany, and design in California, right? So this is not an issue. Here we're dealing with an adversary. And we do have an adversary that's using as a leverage for a variety of issues. One of them is, of course, preventing the rebalancing of the trade account. Why is that so important for China? It's so important for China because, of course, this is an economy of 360% debt to GDP, which you cannot unwind anymore unless you conduct a fiscal reform and rewind 1994 fiscal reform, unless you go into inflation. We know what happened last time in 89, so that's unlikely to happen. Unless you grow at 10%, so far it's not the case. So you're reliant on one thing, borrowing foreign demand, and hence these massive trade surpluses. And so as other countries naturally are trying to push back against this, not all of them are as powerful as the United States, at least in theory, on paper. The friction is there. And so China found a very, very useful weapon here, and it's going to take many, many years to unwind this.
Yeah. So another question is, we start to look at the potential solution to this, right? I know you mentioned there's no easy solution, seems very clear, but let's look at the several, attempt at this. Let me start with this U.S. Export-Import Bank about Project Vault, right? So what's your evaluation of the project? How significant this is to the broader setting here?
Yeah, so for Exim is the largest investment ever, and Project Vault generates a buffer, right? A buffer against the volatility. The participants will have the right and obligation to repurchase the material at the same level, but really only addresses the problem of demand. So it generates some demand for these materials. It doesn't really address the supply issue. And indeed, on day one, the participating traders, initially 3 companies, now more, are perfectly allowed to purchase the material from China. And that's logical because otherwise we wouldn't have any. But you have to really solve the problem of the supply. And this is a longer story. And last year in summer, the US government did one thing which really changed the conditions quite a bit in the market. It offered to a US company called MP Materials a price floor for neodymium oxide of $110 per kilogram. Back then, it was almost twice the Chinese prices. Why this is important? Because one of the problems, of course, the Chinese market operates at much more elastic demand, and it's a completely different price structure. It's not relevant in countries that simply do not produce any. And therefore, that sent a price signal to the market that something's going to change and that the cost of capital for the participating companies will be lower, because naturally you start valuing these companies differently at this sort of level of price. However, coming back to solutions, in order for this to actually function, you have to protect that price with a tariff. And again, not IEEPA tariff, not 122 tariff, something like 301 tariff, USTR, or 201 tariff of ITC, right? Specific for a specific HS code. This has been done actually for lithium at the beginning of this year for non-mobility batteries, right? So this is still a Biden era measure, but just kicked in January of this year. But in graphite, for example, it's been impossible to introduce. Why impossible? Because let's face it, there's also a political economy in this country. And the upstream industry is not powerful, not in this sector. In oil and gas, yes, but not in mineral sector. Whereas downstream producers are politically powerful, and they're going to push back against those tariffs. Think about steel tariffs in 2018. Do you know how many applications for exemptions there were for the steel tariffs in 2018? 40,000. And the graphite story coming back and Tesla pushing back against Biden and so on. This is another example. So you have to incentivize the downstream industry to slowly, gradually move away from a product that's being weaponized by an adversary towards the product which is created either here or in our allied nations. And how do you do it? Well, you incentivize it with legislation, you incentivize it with subsidies. And where do you get the money for the subsidies from? From the tariffs that are protecting that price, all right? So that should be really a comprehensive attitude, in addition to the fact that it cannot be a government giving away checks, hopefully not for much longer, because the government is not the best investment fund and never will be. And therefore, a private sector has to be incentivized for some kind of tax structure to invest in this space. We have the world's largest, deepest, most efficient capital market in the world, and therefore we should not be trying to rebuild what you just very well described as a Chinese system and planning system, because we won't be good at that. But we have the capacity to incentivize significant capital to reduce the cost of capital of operating and producing and investing companies. because this is really our, where we can have a lot of leverage and help companies not only here, but in Australia, Canada, Japan, Korea, and elsewhere.
Mm. Oh, thank you. Yeah. So on that, you're from this investment kind of community there. So what would be ideal situation, say, for your industry to look at this? And if you propose such, what are the resistance you will anticipate? So you mentioned about this political economy within the domestic. Give us a bit more about the struggle between the different involved parties here.
Well, the struggle is that we're coming out of almost nowhere. So there is hardly any mining industry in this country. There's less than 1% of S&P 500. And within this tiny group of 3 or 4 companies, one of them makes some lithium, but the others really don't care about critical minerals. So you have to start from scratch. But starting from scratch, my view is what the government is doing is throwing money at some existing shells which do not have really very good operating business, and they hope that they will be able maybe to consolidate something internationally and stitch those different nodes in the value chain, because this is our attitude in the fund. We can no longer view a specific project completely in isolation of what else is there or is lacking in the supply chain, because it looks like Swiss cheese that John and I used to have, Emmentaler cheese with big holes in the middle. That is really not a solution. You have to look at every single project, how it fits the rest of the supply chain. So some of the movements are very good. For example, inviting Korea Zinc to build a massive refinery in Tennessee, right? That will produce 13 different critical minerals as a byproduct of the process. So, there is a couple of Japanese companies also investing in the United States. This is such a complicated issue. I wish we were working more closely with our allies. I think the government is solving this first through various bilateral arrangements with Australia, with Japan, with Malaysia, and even DRC. The generation of a kind of a club, which is currently the so-called Forge, the Forge program, which was kickstarted back in February, basically replaced the former mineral security partnership, is a complicated network, because at the same time, other things are happening geopolitically, and the US position in the world is changing from sort of hegemonic to something more like offshore balancing, at least when it comes to Europe. Hard to say about the other theaters. So this is a difficult process, but on a specific basis for specific materials, I think it's possible to solve it, and it's possible to solve it first by some kind of a tax reform that would incentivize the investment. And if that investment goes overseas, we have tax treaties with most of our allies. And indeed, if you look at the materials, for example, generated in Canada, Australia, and UK, they are considered in the US by our legislation, Defense Production Act, Title III, domestic sources. So we're actually lucky. We have allies whose material is considered domestic source for our national security. So why not facilitate investment into those companies over there, right? Yeah. From the world's largest, deepest capital market.
Yeah, John, please.
Tomasz, I really liked your example of the spheronized graphite, and this concept that scale begets scale. Much more productive, more profitable if this production facility is close to a steel plant, close to the anode facility, close to a chemical plant, etc. So it feels like we have a very tall mountain to climb in the United States to achieve this type of mineral security that we hope to achieve. It is part of the historical underinvestment in mining. I mean, obviously, people associate mining as a very sort of dirty, not in my backyard type of industry. How do you think that has changed, if at all? Has mining become more sustainable? Is mining done now in a way that, extraction done in a way that it can be less detrimental for the planet and perhaps even beneficial for surrounding communities? Or is it just, it's still just a really dirty business? What's your view?
So mining will never be completely benign. One reason is this is finite. It's a finite operation, right? At some point you run out of ore, even on a 100-year-old Chilean copper mine. It will end at some point, and something else has to replace it, some kind of other economic sustainable activity. And I think in my 25 years in this industry, a lot has changed for the better. We're talking about the communities, the way the communities are in just becoming part of the project for the long term, including the post-closure. This is among the communities that you find the talent. This is among the communities that you teach people how to actually run this business, not bringing expensive expats from offshore. In some countries it's easier than in others, but I've seen many cases of those local folks being sent to mining schools or engineering schools overseas and coming back and becoming important drivers of the local economies in many other contexts later on. So it is possible. Now, other cowboys are the kind of other type of operations. Yes, unfortunately they are, but it's unlikely to find it among sort of large, visible, publicly listed companies that are under scrutiny of shareholders and other stakeholders. So, but I repeat this is always a risky business. It's a large capex business. There's a lot of reagents that go into this. There's a lot of physical movement. It's a reason why there are certain practices and procedures in place, and you have to really comply with that to keep this safe and environmentally less damaging that competition. We see this very quickly when we invest. If you look at nickel, would you rather be in a nickel sulfide underground operation that generates a ton of CO2 per ton of nickel? Or would you be in a laterite open pit operation in Indonesia that generates 40 tons of CO2 per 1 ton of nickel? That's pretty obvious, right? And I think a lot of investors think this way as well.
Excellent. I think we should probably go to the questions. I mean, just one last question from me. I mean, you had mentioned our relationship, the U.S. relationship with Canada, and Canada in particular being quite rich in mineral deposits and so forth. Do you see? I mean, obviously the current administration, I would say, has been, less than friendly to our good neighbors to the north. Do you see that potentially improving? Do you see that as a really important focal area? How would you characterize sort of how the US-Canadian relationship factors into all of this discussion?
So I very much hope that we are at the nadir of this relationship now, and we'll recover from this. This is very detrimental to the future of critical minerals value chains. Canada doesn't only have mining, it has also significant smelting business, both in the West and in Quebec. This is one area where you have 5 cents per kilowatt hour power. So, for anything that's for green transition going forward, it's valuable. There are also some of the elements that Canadian smelting operations could extract for us. Gallium is one of them. Some of those alumina refineries owned by Rio Tinto. So I would hope so that the situation will improve. On the other hand, if you just stick to international relations realist school, then you cannot completely dismiss geography. And Canada, for all its overtures to Europe, will remain in North America. So just as we might not have much choice and we have to cooperate with Canada, so does Canada. And so that we kind of destined to work on this together sooner or later.
Super. Okay, over to you, Bhuvan.
Thanks, John. Tomasz, thank you for that fascinating presentation. Very active chat with a lot of interesting questions and comments. So let me try and thematically combine some of the questions in the interest of time. So I'm combining a question from Mark Helmbrecht and Saul Tannenbaum, and this is on China and how they came to this position of strength that they are in. So was it just economics and lack of investment by other entities and other countries that led China? You spoke about how China, the Yangtze crater, and then they built this ecosystem where scale begets scale. So was this development of this monopoly an explicit goal of Chinese industrial policy, or did they find themselves in an advantage as the materials became critical? So was there a high level of intentionality that we see in all their 5-year policies through the years?
Yeah, so I think there was fortuitous mostly. For a migration of anything or anybody, you need 2 factors, the pull factor and the push factor. There's no doubt there was a lot of pull factor. but it was also a push factor, not just the capital that failed to invest, but also regulatory environment. I'll give you an example regarding rare earths, Nuclear Regulatory Commission that made anything containing more than 0.5% of thorium in those deposits essentially subject to class 7 treatment, which increased costs of operating these for logistics, transportation, handling, and so on. So many mining companies that could previously mine rare earths in the United States simply just could not afford doing this. At some point, at the height of globalization, it didn't matter. In terms of I explained this in my book, Mineral War. In terms of Chinese thinking, I think it's actually before. People usually talk about the China 2025, to the massive import substitution strategy. Industrial policy started even before the GFC under Wen Jiabao in 2006. So we're 5 years of sort of trying to figure out, how the economy could fit within, the broader WTO framework. And then in 2006, the first industrial policies were introduced with some longer term planning. And then after GFC, of course, we started seeing, the total bifurcation in terms of the approach. So the sort of Marxist economics came back, and with Xi Jinping, of course, that sort of accelerated ever since. I would caution against this view that, there's some 100-year plan somewhere there. If this was the case, China wouldn't have the demographic problems today, or environmental, many others. So that's nonsense. But it's true that with the assets they managed to accumulate, some of the technologies midstream, magnet making in the 90s and so on, they put things together, and that was generated into this very, very coherent system with a lot of consolidation and state-owned enterprise also control over an industry which was initially actually to some extent private, especially in the southern part of the country.
Thanks so much. So shifting gears a little bit, and John actually asked this question on, has mining become cleaner and benefiting the community since the last 25 years? And you mentioned that it has. You have seen some benefits. So again, combining two questions from Professor Kara Kockelman and Jack Nilles on that many developed nations, there's an unwillingness to strip mine and build pretty dirty smelting activities. So has this slowed down the deployment of these industries? And to flip it, the question from Jack is, would relaxing environmental rules around mines, processing plants have a significant effect on rare earth production in the US? And if so, how long would it take to expand its production?
Let me address the second one. So just relaxing is not a solution, but finding a proper way to handle radionuclides in the waste through new piece of legislation would be helpful, not just for North America, but also Europe. There's no way to redevelop this industry without actually finding the right solution for deposition and handling and management of waste, which is mildly radioactive. About smelters, this is actually quite concerning. What's concerning is that many smelters in China functioning are basically underwater. So if you're a smelter, you charge your mining source of feedstock with treatment charges or treatment and refining charges, depending on the mineral. Many smelters in China function at 0 TCs or TCRCs or even negative TCRCs. What does it mean? Nobody in the world can compete with them. So Chile, which has the world's largest copper industry, just shut down its smelters. Right now, it doesn't have smelters. We see this deindustrialization going in Southern Africa. A zinc smelter in Namibia had to close. Aluminum smelter in Mozambique. Another Glencore smelter in South Africa. Another one in the Philippines. In Australia, they're teetering on the brink of disaster, with some Australian government money potentially saving them, and the same in Europe and same in Canada. So this is a serious issue. While China already controls, 60, 70%, sometimes more on some of these. And it's not stopping, because at the last 5-year plan, the decision to foster productive forces and, modern industrial development pushes it further towards production away from consumption. Consumption is like distant number 3 there. So someone will consume it, right? This is a country now, 17% of global GDP, 32, 34% of global manufacturing, aiming to become 40% of global manufacturing. This is not what David Ricardo taught us about economics. This is not comparative advantage. There was never an idea that one party just produces everything and others nothing. But I'm saying this because in Shandong right now, there's another new copper smelting center and refining center being built. So regardless of what your legislation is regarding environmental protection and so on, you're currently without significant support, and in this case, support from regulators and government money to even save the existing operations. This is going to be an uphill battle.
So we mentioned national security, and John, you mentioned this, in your slides as well. And if that is the keyword now, and we need to produce more drones and devices, weapons powered with magnets for the new warfare that we are seeing these days. So shouldn't there be a concerted effort by Washington to reduce production of other devices that use the same materials like turbines and EVs and maybe they're doing it, I don't know, but this is just a question. Jane Gould actually had this question. So, or should the policy be that we want EVs and wind turbines that use similar materials as well, and or do we divert from EVs and wind turbines to drones, the batteries, and the motor materials? So that's, and John, feel free. I think both of you, this is a relevant question.
So there's no doubt that direct drive motors of wind power, especially offshore, are the largest civilian market consumers of rare earth permanent magnets. And my suspicion was precisely that when I heard about the sort of crusade. It's almost like reading Cervantes again now against the windmills. We're fighting windmills. So it's that was my suspicion, but I don't have any security clearance, so I don't know if this is true. Let's not forget, usually military market is much smaller than the civilian market. For some of these, not more than 5-8% of the market. But let's also keep in mind that military budgets are exploding, not just here, in Canada, in Europe, in Japan, in Australia, in India, and everywhere else. So it's possible that this is the drive. However, you will not have a development of this upstream industry unless there is a significant source of offtake downstream, right? So that could become also counterproductive in the longer term, depending how the global situation evolves.
John, anything to add on, don't divert, but actually build the downstream supply chain base so you can always have the optionality to service your smaller military market?
No, I honestly, I have no idea. Clearly we've seen examples of that through history, right? Where critical resources, materials, fuel is, protected for military application. I don't know if that's particularly the case here, and I just certainly hope it doesn't get to that point, because, for those of us who appreciate clean energy technologies, we certainly want to continue to have access to those technologies and to, continue to address other serious issues like climate change. So I certainly hope it is not the case, but I can see Tomas's argument that it certainly could be the case.
Yeah. May I ask another sense of the substitution, the technology sense of the substitution, right? Thomas, can you give us a sense among all these different minerals and rare earths, etc., which one at least have some potential that you can find a substitute for, right? Which one is just hopeless, so we just stuck with it.
Right. So if we just talk about the magnets, right? Well, it's possible to use externally excited synchronous motors, right, or asynchronous motors that do not require rare earths because they generate the magnetic field themselves. In terms of those that are magnetic, ferrite magnets are a solution. So ferrite magnets will have probably the power, the magnetic energy product of about 1/10 of rare earths sintered magnets, but also cost 1/10, right? So overall, it's just then a question of size and packaging and so on. And in this area, although China dominates ferrite magnets, it is actually, this is very interesting. China is dependent on imports of the key element for it. That element is strontium. Where do you think China imports this strontium from? From Iran. Okay, it's either mined as a celestine or is produced as strontium carbonate, and so it's necessary for those magnets. So there are a couple of others. People look at, of course, iron nitride and other types of formulas. Protoriol, so the former Hitachi, recently sort of publicized a high-end sintered magnets, so those that do not lose their eminence or coercivity at high temperatures without dysprosium, so heavy rare earth with which those more generic alloys have to be doped for performance. So apparently it's possible to avoid dysprosium. Therefore, one of those heavy rare earths, which are almost completely controlled by China. I'm saying almost because I just saw in Malaysia on a plant the first dysprosium oxide available to Western, in this case, Japanese off-takers downstream. So it's, obviously, with this level of pressure, there's going to be a lot of solutions, and there are plenty of solutions at the lab level. The question is taking it above the pilot and demo and scale it up properly. And here, our capital has failed over a long period of time, looking for labor arbitrage, environmental arbitrage, and all of these other things that, of course, push this industry away from the US.
Yeah, I honestly feel like, Genoa, that's the key question, this issue of substitution. And, yes, places like MIT can contribute to that, to innovating our way out of this pickle that Tomasz has so clearly articulated. But with that caveat that you just mentioned, Tomasz, that if we can't produce this at scale, if we can't bring the technology out of the lab and into that industrial ecosystem, then it's just not going to happen. And that requires a much more coordinated approach among a very wide group of stakeholders. And that becomes a human challenge right there, to make that happen, to realize that vision.
This is very true. So I also count on Professor Zhao and everybody else. But just to remind you, LFP batteries were invented here. NMC batteries were invented here.
Yes,
here
all
in
of this.
Japan. The permanent magnets between Japan and General Motors, all of this was invented not in China, and yet this is where we are.
Yes, exactly.
So maybe one last question, and again, open to both, John and Tomasz. We've had Gil Pratt, who's the chief scientist at Toyota, talk about this in the forum before. So Christos Xenophontos asked this question that given the average daily commute of people in the US is only about 40 miles, wouldn't the Toyota solution of investing in plug-in and hybrid models that use maybe 1/10 of the battery capacity and maybe lesser rare earths, is that a better solution instead of putting wasting the minerals in an EV that the range is not used on a daily basis?
Yeah, but I think this is where the market is going. This is what sales are showing, right? At least last year. So maybe it's not a decision rationalistic top down of someone deciding that it should be what it is, and just let the customers decide. I think this is exactly where it's heading now.
Yeah, and it's a point that Gil Pratt on our advisory board and the chief scientist at Toyota has very eloquently made many times. For X amount of material, if you spread it across more vehicles, you will actually have a greater impact on reducing greenhouse gas emissions.
Yeah, great point.
Great, it's 1:00. So thank you so much, Thomas, again for this conversation and also presentation, and also raising the awareness across the nation to really take this seriously. Everybody, please join me. Thank Thomas and John for today's presentation.